Okay, g'day. So for this exercise, we've been given a game and we've been asked to eliminate rows via dominance rules and then proceed to solve the game afterwards. So I'll jump straight in and start solving some of these, eliminating some of these rows. Better not mix those words up too often. Alright, so for player 2, we can instantly see that column 1, our first column, is every element is larger than its corresponding element in column 2. So we can see that 3 is larger than 2, 0 is larger than -1, 3 is the same, 0 is larger than -2. So they're all larger than or equal to an element in column 2. So we can go ahead and remove this column from our series. Same with column 4 and column 5, as both of those have elements, all of their elements are larger or equal to column 2. Now looking at player 2, we can see that row 2, every element in its corresponding element in row 4 is larger than, so every element in row 2 is larger than every element in row 4. So we can go ahead and remove row 4, as player 1 will never choose row 4 over row 1 since it will always be its optimal solution. Now, if we go and set our two columns to be y1 and y2, we can write this out as 2y1 plus 3y2 negative y1 plus 4y2 3y1 plus 2y2. Okay, cool. So we'll chalk this up, and we know that 1 equals y1 plus y2, since this is a probability. And we also know that y1 and y2 are greater than 0, greater than or equal to 0, because we know that it can't be negative. And from this, we can also get y2 equals 1 minus y1. Rearranging our first top equation there. And I'm just going to go ahead and substitute that in for our y2 value. And we will get 1 minus y1, 1 minus y1, and 1 minus 1 y1. There we go. Awesome. So we all know how to solve to get those three equations. And after we solved, I've gone ahead and graphed these up already. The answers, that is. So we've got negative y1 plus 3, negative 5y1 plus 4, and y1 plus 2. These are our three equations right here for our matrix. And I've graphed them up. And as you can see, for this particular instance, player 2 we're trying to minimize for player 2, because player 1 is going first, so player 1 is going to try and maximize their roll, so they're going to pick the best option, which will be anything along this line here. That will be player 1's best pick at all times. And player 2 will want to pick the lowest point along that line, which will be this point just here, which is the intersection between y1 plus 2 and negative y1 plus 3. So we know straight away that 2y1 equals 1, and that y1 equals half. And of course, from our rule earlier, we know that y2 equals half. Now I'm just going to quickly jump over here. So now we can start doing our optimal strategy for x. So we know not to use the middle row because the first row and the third row were the intersecting lines for our previous graph, and that'll leave us with, I'll write it just down here in the corner, 2, 3, 3, 2. Now, something interesting to note about this is that you can look at your R value, which is R equals, this is for solving the 2 by 2 matrix. You can see that R equals A plus D minus B plus C. Now, if we have A equals D and B equals C, we can immediately go ahead and set this as R equals A plus A minus B plus B, which just gives us 2A plus 2B. And then for our optimal strategies for x prime, we will get a minus b, comma, a minus b, over r. And from here we can show that it equals half over a minus b. This is just through simplification. So let's just multiply, and we know that a minus b over a minus b is equal to 1, so we know that it's just half. Oh, sorry, that's also, I didn't do the second part there, so it's just half comma half. So we just know that x1 equals half and x2 equals half. And you can apply this to any 2x2 matrix that you get where both solutions are, so if A and D are equal and B and C are equal, you can apply this to anything. So for our situation where it's 2, 3, 3, 2, we know for certain that it's half, just the same as we would if it was 1, 1, 4, 4. And that is how you solve this given matrix, or I should say this given game. So thank you for watching.